Hello, friends.
Hi, Tori.
How are you?
Good. How are you?
Good.
I'm going to be eating my lunch, so I'm going to mute myself.
No problem. I just did that right before we started. Let me give folks just one more minute to hop on and then we'll get going. Hey, Grace. And hi, Emily.
Hi, sorry, I'm also eating lunch right
That's
now.
okay. All good. Though this is going to be a little bit participatory. Like I'm going to orient everybody to the simulator, but then I'm going to ask you guys to choose what we simulate. And hi, Ms. Amjad and Ms. Reed. All right. Well, I think I'm going to get rolling just so that we don't waste people's time just sitting on a Zoom. And let me close this for a second, move this over. And I'm going to share my screen so you guys can see what I'm looking at. All right, so hi, welcome. Thanks for coming today. How's everyone doing? Good, I hope. So I recently did a webinar on this simulator called the NRoad Simulator, which was developed by MIT Sloan School of Management in conjunction with two other groups, Ventana Systems and a group called Climate Interactive. For those students who are on today, Climate Interactive is the same group that developed the World Climate Simulation that we were going to run. Thursday we were going on break, before break, and then we canceled it because of the whole mess with canceling school and whatnot. So there's a lot of science in the on the back side of this. The inputs and the sort of system dynamics that are programmed into this simulator are drawn from all sorts of reputable resources. So like the data sets are from places like the Energy Information Administration and the Intergovernmental Panel on Climate Change. And then they've got a whole suite of climate experts that have worked on developing the sort of simulator. So what it does for us is, if you look over here, you can see there are like a whole suite of different kinds of graphs that we can look at. And basically this is a decision-making tool that tries to help policymakers figure out like what are the most effective tools that we have in our toolkit to try to combat climate change. And it does that by running the simulation of like, if we increased renewable energy, like what happens to the energy sources profile, right? You can see those graphs shifting as you go. And then over here on the side, you can also see that it tracks the temperature rise. So do you guys remember, or do you know what the sort of target maximum temperature rise the international community has set for itself in the Paris Accord?
Is it 1.5 degrees?
Yeah, so it's like there are two different numbers that are out there. One is 1.5 and the other is 2 degrees. So the international community has basically said we cannot let it go over 2 degrees Celsius, and ideally we're shooting for 1.5. And the discrepancy between the two is like 2 degrees. Scientists say, if we go above 2, we're likely to see like truly catastrophic changes that we can't really adapt to effectively. At 2 degrees, we still will have significant changes in the way our world works, but those are changes that we're likely to be able to accommodate and adapt to in some way. Obviously, the impacts on different regions of the world and people in different socioeconomic groups are going to be really different. So when we say like we can adapt, for some people that adaptation is going to be much more difficult than for others. The 1.5 degrees Celsius marker is was really pushed hard by low-lying countries of the world and island nations, because they basically said, look, if we get to 2 degrees, we're gone. Like our whole land mass in some of these low-lying islands is like gonna be sunk by ocean level rise. And then other countries like Bangladesh, which have huge populations that live in low-lying floodplains along the ocean coasts where they do farming and agriculture, trying to imagine like those zones flooding and what would happen at the 2 degree mark is still really profound. So, you know, a lot of people were pushing for the 1.5 in areas where they've got a lot of low-lying land with ocean coastlines. So what I wanted to do today was actually see if you guys, give you a chance to play around with this, and I'll run the simulation for you, but like, what are you curious about that you've heard, like, oh, I've heard that doing this would be really helpful. Like, let's run that scenario. And then if we don't understand, and actually for each of these toggles, there are sub toggles within them that we can mess around with even further. So, right, like if we're interested in advancing renewable energy, we could apply a tax or a subsidy to renewables, and then we could tell it when to start doing that, and things like that. And we can see what sort of the impacts of those things are. So maybe you guys have things that you've always wondered, like, would that really help? Or I've heard that this would help, but I'm not really sure. We can go explore those. So this is where it becomes interactive. Let me go back to the default graphs and get out of that. So does anybody have something that they've heard about or wondered about in terms of like, what would the impact be if we did X, Y, or Z?
Can we look at carbon tax?
Yeah, definitely. So I'm gonna do the subtoggles on that. Do you have a particular price in mind?
Not really.
Yeah, it's kind of hard to know sometimes, like where you should start, right? Like if you don't have any background in it. So we can mess around with the price. We'll play around with that slider. Do you want to start that carbon tax right away, or do you want to give us like, oh, in 5 years we'll start it?
Yeah, maybe 5 years.
Okay, so we started in like 2025, and let's see, we just said start that in 5 years. Do you want your carbon price to ramp up over time?
Yeah, sure.
Okay, so let's just say we started it at like, I don't know, $15 a ton. Did you guys see that? Watch the graphs up above. I'm going from $0 a ton to 15. What just moved there?
That brown line, coal, wow.
Yeah, so coal's dropping, oil's dropping, natural gas not dropping quite as much, right? And then let's say we want to ramp it up to, I don't know, $150 a ton would be considered really dramatic. I think that's a very high price, but let's try that. And let's say we're going to achieve that final price, I don't know, like 2050. I'm not sure why this gives, let's see, we want That gave us what, 30 years to achieve it? Is that right? No, 25 years. Okay. So what do you guys notice going on here?
It definitely flattens it a lot.
It definitely flattens it. Does it do it? Does it do the full job?
No.
No, right? So a carbon price helps, but it's not going to be the only thing we need to do, right?
Yeah.
This one, you can sort of see it scaling up. It really seems to kick in when you put the higher price on, right? At 2050, it starts to really, as you ramp up. Let me see.
Is the price for everyone, or is it just for like top consumers of
So
carbon?
typically with a price on carbon, what they do is they apply the price at the point of production, and then it would trickle down through the economy depending on how different manufacturers or whatnot like choose to pass that cost on or not. So does that answer that question?
Yeah.
Yeah. All right, so carbon price, pretty effective. Anybody want have something else they want to mess around with? Adults who are in this, you can chime in.
Can you increase the energy efficiency of buildings and industry?
Yes. Let's see what our sub toggles on that are. And you know what, I'm going to clear out the carbon price so we can see it exclusive of the carbon price. So building efficiency, let's say we make it, I don't know, like a lot more efficient. Oh, see, and down at the, you can see that says like it's increased, now it's highly increased. Building efficiency. And that's starting it right away. And that's setting it at 5% of buildings are getting retrofitted every year. So let's say like, well, maybe that's ambitious. I don't know. What if it's only 3% getting retrofitted every year? How much does that impact it? That doesn't seem to impact it too much, does it? A little bit. Let's say we did like 20% a year. So it took 5 years, what, that would be 5 years then to do all the buildings.
Oh, good.
Ms. Mueller just joined us.
Hi.
Hi,
Hi, how are you?
good, how are you?
Fine, thanks.
We're just basically messing around with this simulator. So people are tossing out test cases of like, what if we did X, Y, or Z, and we're looking at what some of the impacts are.
Okay, great.
So if you've got something you wanted to simulate, we can do that. The other thing we can do on here is we can look at other kinds of sort of output graphs. So if people are curious, like, well, what happens with the, here's one that I'm kind of curious about, have been curious about in the past. Did that sort of do what you wanted to do, Nicole? Or sorry, Ms. Trombetta?
Well, I mean, I of course wish it had gone down more, but
Right.
but I'm like thinking of like with like lead status and all that, like lead platinum, and how much of a difference does that really make when buildings, achieve lead status?
Yeah, I think one of the things that I was interested in when I was looking at sort of the background information on the simulator, they said that some of the things that we think might make a big difference don't act fast enough because of the turnover time it takes, right? So the fact that they have the rate of retrofitting in here, that's an important element to that question of like, how much impact can you have with building retrofits or like energy efficiency advances? Well, it depends on sort of how often those manufactured goods or the sort of the thing that you're using that uses that energy turns over in people's lives. So like you could have electrification of cars, but if it takes a really long time, it's like a, probably like an 8-year cycle for people to get a new car, a 6 to 8 to 10 year cycle. So you know, first they need to become affordable, and then you have to actually get people to want to buy a new car, right? Like they're not just going to like, most people are not just going to up and sell their old car and get a new one just because an electric vehicle is now available.
Right.
So some of those things take longer to work their way through the system, and then because of that don't have as big an impact as we would like, as quickly as we would like. So the one that I was messing around with a little bit is this afforestation piece, which is basically what happens if we plant a lot of trees, right? Because the carbon, what was that?
That was going to be the next one I asked
That
for.
was one you wanted to do too. So I'm going to switch up the graph on this one actually, because what's interesting here is we know trees are one of the ways that we can actually remove carbon from the atmosphere, right? So we're putting it up there, but we've now already put so much up there that we actually have to be pulling it out to get ourselves back to that 2 degrees Celsius projection, right, that we're trying to hit. It's not going to be enough to just stabilize our emissions. We actually have to get to the point where this red line, which is carbon emissions, has to be lower than the carbon removals to start drawing down the amount of carbon that's already in the atmosphere. And that's one of the things that I think people often miss in the sort of solutions to climate change equation, is that stabilizing our emissions or even lowering our emissions isn't going to do the trick, because the emissions have to lower enough to get below the removals line, right, in order to start drawing down the total concentration in the atmosphere. So one of the ways we have to do that is planting trees, as I said. And there is actually limited land area on which we can plant trees. So that's one of the things that this takes into account, is that we can't just like cover the whole planet with trees, right? Some areas are not suited to growing trees, and other areas, like we have now colonized it basically to the point that we can't just cover it in trees. So here we can set like how much of the land area that's actually available for planting trees are we going to plant out in our scenario. And then how long is it going to take us to do all of that planting, right? Because if you're planting, you know, in a land area the size of India, you're not going to plant it all in 1 year, right? You actually have to allow time to plant the trees. They actually also have in here how long it's going to take you to secure the land, right? Because we may not even own the land or have access to the land that's available for planting. A lot of it is probably privately held. And so you then, like in the Cleveland Tree Plan, actually, this is really interesting to think about. They said like 80% of the area that's available for planting trees in the city is privately owned. And so in order to execute the Cleveland Tree Plan, which is very ambitious, the city has to work with all these private landowners, right, and get access and get them to want to plant trees too, right? So there's like a big time lag in that of like, let's get everybody on the same page to get the sort of the planting to happen. So let's say we start the project in 2020 and it takes us, I don't know, maybe it takes us just 5 years to organize all of that, right? We've got a very ambitious program. And we're gonna plant out, let's see, we didn't set, how much land do you guys want to take of the available land for trees to plant? What's our percentage going to be?
Well,
should we plant it all and see what happens?
Sure.
Just to see? So
Yeah.
let's say we did everything we could. And we did it, yeah, sure, over 30 years. What happened?
not enough.
Yeah, not much, right? Like, look at that red line and the blue line.
Can I make a comment on this?
Yeah, hi, Katie.
Hi, how are you?
Good, how are you? For those who don't know her, this is Katie Fragang, class of 70, who's been a grand supporter of the Center for Sustainability, so I invited her on today.
Fantastic. Hello.
She's one of our alums, yeah.
There's a lot of research now, and it's, I actually heard a Audubon lecture recently, and they even cited all this research. It's coming out of Boston, which is talking about the fact that planting trees is just too hard, and that because the biggest reason is that a tree takes a certain amount of time to be able to give off enough to do its job. And so really preserving old trees is the way to go. So conserving land, existing land, speaking to landowners, when you speak to landowners, I wouldn't look for land to necessarily plant more trees as much as to encourage them to preserve their existing trees. So the conservation people are realizing that in terms of timing and making all this happen faster, they're the people on the front in terms of developing this huge conservation plans for old forests. And the data on old forests versus young forests is 100 times better in terms of doing the oxygen, the carbon dioxide removal job. So that's really, in terms of a plan, that's a better track to take.
So I feel like you just tossed us our next scenario to run, which is to see what happens if we can reduce deforestation. So let's say we start right away, and if we can keep our forests intact. We still don't get a lot of change, unfortunately. We get the drop in gigatons of carbon dioxide emitted per year, but you're not seeing a huge shift up here in terms of the emissions and removals, right? You get a little bit.
I think this is referring to, isn't this referring to South America and places where forests are being cut down for making, I don't know, cow pastures or something, and as opposed to I'm curious to know what data they're putting in to generate these numbers, because it seems like they're focusing on a certain kind of scenario.
So this is where I'm jumping over to their user guide, which gives a little bit more detail of what's sort of in the background here. So indeed, they're talking about forest clearing for agriculture.
Yeah.
Let's see. Model structure, emissions from deforestation stay level. Let's see, the key dynamics that they say are at play in the background. Highly reducing deforestation emissions reduces temperature less than most people would estimate, but they don't really say why. Yeah, in their scenarios as they're running it, it's a relatively low leverage for the climate. Oh, here, because the influence from energy CO2 emissions is so dominant, but stopping deforestation is still a part of a multi-pronged effort to address climate change.
Yeah.
All right. Any other scenarios people are curious about?
Can we reduce coal?
We could reduce coal.
Please.
Do you want to do it through a tax, or do you want to just say we're going to reduce it by a certain percentage?
Let's do it by reducing it by a certain percentage.
Okay.
$25.
We get rid of coal completely. That's a pretty dramatic drop, actually.
Yeah.
That's the most dramatic we've seen, actually.
Yeah.
Let's see, I'm going to go back to the energy graphs we were looking at the beginning. There we go. I'm curious if we were to do it instead of just saying, like mandating it, if we did it through an economic policy, what happens? So if we start to tax it like right away, oh, there's more down there, sorry. Stop here, stop building no new coal. Oh, should we stop building new coal infrastructure?
Yes.
Oh, look at that.
Yeah. Wow.
And then we can accelerate the retirement of coal plants. Or we could put in, do you guys know what carbon capture and storage is? Have you heard of that?
Uh-huh.
Yeah, so should we make them start to capture carbon?
Yes.
So let's see. Didn't seem like it did much, did it? I'm trying to figure out which way is a tax and which way is a subsidy.
If we've stopped building new infrastructure and accelerated their retirement, then
That's true.
probably not going to have that much effect.
There. Okay, so if we subsidize carbon capture and storage, it actually increases how much coal we're using.
Yeah.
But we still get a decrease in temperature, right? Because it's not emitting the carbon. Interesting. If we tax it,
Yeah.
we tax it a lot, you get something. So I think the question for me, maybe in the last, we've got a bit of time still, but should we try to put together a scenario where we can actually get to 2 degrees as the maximum rise by 2100?
Yes.
Yeah. Wait, quick thing though. I was kind of curious to see like what nuclear would do.
Oh, great question. Yeah, let's go there first. Okay, so do you want to tax nuclear or subsidize it?
Subsidize.
Okay, we'll subsidize the heck out of it. Highly subsidized. And then start it right away. Keep it going till the end of the scenario. Nuclear research and development breakthrough cost reductions. So should we anticipate that there's going to be drops in the cost of nuclear through breakthroughs?
Maybe a little bit. Yeah.
Okay. And that the breakthrough is going to come when, Grace?
2050. It's like.
Okay. So it helps some.
Yeah.
Let's go back and watch what happens to the other energy curves when we move this one around. So interesting, the renewables is dropping down, right?
Yeah.
So as you subsidize nuclear, you get less renewable development too.
I heard there's like a trade-off in like government subsidies. Like they only ever like do one or the other. That's like, or like, I don't know. It's not like black and white, but.
So they would tend to only focus on one sort of energy sector. If they were going to subsidize, they wouldn't subsidize both. Is that what you're saying?
Yeah, because I actually debated this topic and like people were saying that like if you subsidize nuclear, then it takes away from renewable subsidies, and I don't know how true that is in the status quo, but yeah.
So I'm going to leave that nuclear subsidy in, and let's go see what happens if we also subsidize renewables, right?
Yeah.
So we get a big climb in renewable, but then you get a decline in nuclear, right? Even though it's still being subsidized. So this was one of the interesting dynamics that, and then in terms of our temperature change, actually, let's see if we can look at that as the, impacts. Let's look at the CO2 concentration on that one too. Those two will mimic each other. One of the things that they mentioned in sort of the background dynamics on this was that if you're subsidizing both renewable and nuclear, then the two become competitors with one another, and you actually don't get the sum total. Like if you just did nuclear or you just focused on renewable, you'll get a bigger, like let's say it drops the temperature by 0.6 degrees for each one of those. But if you put the two of them together, you don't get a sum of those two in temperature drop because they start to compete with each other. So you don't get quite as much impact from the two of them together as you do from each one sort of individual. Does that make sense, Grace?
Yeah.
All right, so if we go back, what have we learned so far, and what do we want to try to get to a 2 degrees Celsius?
Cutting down on coal definitely helped a lot.
Okay, so I'll go in here and do that through just like a mandated reduction. Is that what we were doing?
Yeah, I think so.
How much do you want to mandate, Emily?
20%.
Okay. Anybody else?
Do they have a model where we can see what it actually takes to get to 2? I am shocked at how little these individual pieces do. So like, what does it actually look like and take to get us to 2?
Oh, that's a good question. I don't know that they have one built in for us. Let me see.
It's kind of sobering, isn't it?
It is a little sobering.
Yeah.
You know, there might be one in the video tour, but I haven't looked at it, Ms. Miller.
Okay, I was just curious.
Yeah.
Very interesting to see this.
Yeah, I think we messed around with the carbon price earlier, and that one had a pretty big impact. Should we go back there?
Yeah.
That'd be great.
So let's make it a medium carbon price.
Yeah.
Take it to $50 a ton, starting right away. We'll start it right away at $50 a ton. And we'll keep it at 50. It's not going to escalate up.
It seems like these things are contradicting each other unless we don't, like, or they should, you know, like auto-populate based on.
It does seem like it, doesn't it?
Yeah.
Yeah, I'm inclined almost to just like do the basic slider on that one.
Yeah.
Yeah, exactly.
Let's just put a medium carbon price on. Okay, so that got us.
Renewables.
What was that?
Increase renewable, like subsidize renewables, but don't subsidize nuclear.
Subsidize those. How much do you want to subsidize them, Ms. Trombetta?
A lot.
The whole shebang?
Yeah. Do it.
Yeah.
Okay, highly subsidized renewables.
What about that new technology?
Ah.
Yeah, I was curious about what they thought about, like what was like, okay, that's what I was wondering if it was going to be.
Very generic.
Yeah.
Yeah, okay.
Fuel cells.
Should we assume that we're going to get some though?
Yes, let's go ahead and put that all the way up.
Huge breakthroughs.
Yeah, huge.
Yes.
Huge.
We make that happen this year.
Nobody's talking about population. Do we want to mess around with population at all?
Ooh. Population.
What if we held at 7? Can we hold at 7 billion?
Let's see.
A lot of Europe is now achieving 0 population growth.
Right. So if I
Put it
take it
zero.
down
Okay.
to 1 base, well, it doesn't let us do that.
Okay.
Apparently that is too unrealistic a scenario to deal with.
Too radical.
Too radical. Let's say we've got as radical as we can go, of very low growth. We're at 3.1.
How about transportation? What if we could up and maximize energy efficiency and electrification on both of those?
Okay.
Now we're down to 3.1, so we're moving in the right direction.
So we're improving our transport energy efficiency by 5% a year, starting
Oh,
right
that gets
away.
us down to 2.9.
We're getting somewhere, and then we're going to electrify.
Yes.
Um,
Thank you so much.
Ooh, that doesn't-
5% a year electrification.
That didn't change anything, did it?
It did not change our temperature.
Tesla's in trouble.
Interesting. Maybe because we already put in the energy efficiency measures so high. Or maybe we need to adjust our energy production mix, right? Like if we're,
Right.
we need to change the oil profile maybe.
Mm.
No, electrical wouldn't do that. No, should we ramp up nuclear?
We don't want to do that though. But then
Oh, then it goes back up.
Isn't that where it competes with renewables?
Yeah.
I'd rather have more renewables than more nuclear.
Oh, we didn't do any of our buildings.
Oh yeah,
That was helpful, right?
Yeah.
So we're going to make them as efficient as we can. Oh, that helped.
That helped a lot.
Should we retrofit them even faster?
Yes.
Yeah.
We're going to retrofit 20%. Did that do anything?
It didn't.
No.
It did not achieve any help for the temperature. That's interesting.
Interesting.
Okay.
Wait, maybe it's because it's just like assuming like it's not about like how fast you do it, because they're just looking at the increased temperature by 2,100.
Oh,
So
true.
it's like yeah.
But you should see it on the graph here, right? Like you should see
A little bit.
some impact from that.
Tori, do they have the that young man, and I think he's in Denmark, who is actually working on a microbe that would eat carbon, and it would be the first actual active way of removing it. Is there any button here that represents that kind of technology?
Yes, technological carbon removal.
Ooh,
Yes, let's try
do
that.
Should we maximize our potential there?
Absolutely.
Yeah, assume that we really make a breakthrough there.
Woo! Look at that.
Oh,
Yep.
let's put our money there.
Yes.
And then we could plant some forests, or yeah, do some replanting.
And that gets us there.
We just solved the energy crisis.
We did.
The climate crisis.
Send this off to our policymakers and tell them
does
we
it.
did it for you. Here's what we need to do. So in our last 5 minutes, I would love to hear from folks who have been on the call. Like, what does this leave you with? What does it make you think about?
It makes me think about something Elizabeth Colbert pointed out in all of her written work and interviews. She was one of the most dynamic guest speakers I think we've ever had at HB. Honestly, there's not a day that I don't think about her talk. But the train left the station so many decades ago when people were mocking environmentalists, and seeing this model has shown me how hard we have to work, but also that it's doable, so that we need to stop making excuses, buckle down, and just start subsidizing and doing the right thing. You know, our coronavirus pandemic is related very much, they think, to climate change. More animals coming out of the forests as their habitat disappears. And the CDC thinks we're going to see more pandemics. So there should be an urgency to this that hopefully models like this can help people tap into. I hope.
Anybody else?
Like, I don't think, like, I realized how drastic, like, the change, like, we need, like is, because, like, I always thought that, like, I never realized how small an impact, like, each individual, like, action in this, like, has. And yeah, so.
Yeah, that there's not going to be like one answer.
Mm-hmm.
Right.
Like if we just do this, then we've solved the problem. It's everything is so interconnected.
Yeah.
I think that's what we had to emphasize that point. I was just talking to my advisor group this morning about, because they're asking what we're doing next in science, and normally we would do clean energy next, and then our unit on light and color to end the year, and now we probably don't have time to do both. And I was like, oh, which one should I do? I'm like, well, okay, now I know which one I'm going to do.
Excellent.
Decision made.
Yeah.
So I've had to go teach them right now. So so thank you so much, Tori, for this, and I'll probably be emailing you to ask more about this program.
Perfect.
So thank you, I appreciate it.
Good. Yeah. Thanks for hopping on, Gambetta. Emily, do you have any thoughts that this is leaving you with?
Yeah, I guess, well, there's a lot of different, you know, areas that we can all work in. I feel like definitely some of them had a bigger impact than others. So I think, like, if we're looking towards making a really like drastic and quick impact, that it might be smarter to focus on certain areas as opposed to other ones.
Mm-hmm. Yeah, I think for me, it's, I mean, not that different than what you guys are saying, but I'm always struck by the need to move quickly and to move in all sorts of different areas, right? That it's not one thing that's going to solve this for us. And to be pretty aggressive with it. Like, you have to, if you look at what we did here, highly huge breakthroughs, right? High growth in technology.
Right.
So we didn't really ramp up the carbon price, and most of the other ones, though, we sort of went to the highest settings enabled on it, which I'm struck by. I just watched a movie that's streaming with the Cleveland International Film Festival. Today's the last day you can stream it through them. It's called 2040, and it was a movie that imagines what the world could look like if we employed some of the technology that we have available right now, and sort of scaled it up really fast to try to address climate change. And it was really nice in sort of partnership with this simulation, because it offers a very hopeful picture of what we could do without having major technological breakthroughs. This simulation tells us, like, that's not going to do all of what we need to do, but it does at least provide us a window into what we've got right now that we can ramp up. So if anybody's got time tonight and wants to stream that, you can get it through the Cleveland International Film Festival. Again, it's called 2040.
Great. And doesn't even seeing the pictures of cities post having people staying at home, surely that is inspiring. I mean, pictures of Venice with porpoises in the canals and animals roaming up and down streets, but I just can't get over the image of how blue the sky is in China. I mean, for the first time in probably half a century, as well as our own cities showing just a tremendous decrease. And I hope, I mean, it's obviously been a horrific situation, but there's so much we can learn from it. And there would be a balm in knowing that we've become a better species and more interconnected if we can take away some of these things moving forward. I really hope we can.
Well, we have hit our 1 o'clock mark. So I want to honor everybody's time and thank you for spending 45 minutes with me playing around on this. This is available online for free. You can just get onto climateinteractive.org and find it in their simulation tools if anybody wants to mess around with it more. They've also got some like class lesson plans and things that if you wanted sort of a guided exercise with it, they would take you through it.
Fantastic. Thank you so much. It was fascinating.
Thanks.
So good to see everyone. Bye.
Thank you for inviting me.
Thank you.
Glad you were here,
Thank you
Katie.
so much.
Take care.
Bye.
Bye. You're so nice to have come on, Katie.